Welcome, restless thinker, to Science of Sleep. Tonight we slip into the quiet river of time itself. We will trace how every second stretches or shrinks under forces we seldom feel: speed, altitude, gravity, yet, which shape the ticking heart of the universe. If this gentle voyage settles your mind, tap subscribe and ring the bell so we can meet again beneath the patient clockwork of the cosmos. Imagine holding a simple stopwatch at sunrise. You press the button and wait while dew beads tremble on grass blades. 1 second passes. In that same instant, a jet pilot high above, a physicist beside a mountaintop clock, and an astronaut coasting over the dawn line, all live versions of a second that are slightly different in length. Time is not rigid. It flows like silk over stone, yielding to motion and mass. Our journey begins in a laboratory hidden behind concrete. Inside, clouds of cesium atoms vibrate at roughly 9 billion beats each second. These atoms define what most nations call the official blink of time. Identical clocks sit at sea level, on alpine terraces, and aboard satellites drifting far above weather. By sending laser links between their devices, scientists see the alpine clock gain a handful of nanoseconds every day, while the satellite gains a little more. Gravity has relaxed its grip, letting their seconds expand. Engineers subtract that gain each morning. Without the correction, GPS maps would skew, and the blue dot on your phone would wander across whole city blocks. Though no hardware failed. Shift to a Valley Physics Hall, where students examine muons, short-lived relatives of electrons. When born high in the atmosphere, these particles survive only about 2/millionths of a second in their own frame of reference. Yet detectors on valley floors record a flood of them. How? Because they plunge through air at nearly light speed, and at such velocity their inner clocks drag. What is scarcely a heartbeat for us becomes a stretched eternity for the muon. Enough for it to reach Earth and ring the sensor like a messenger outrunning its doom. Relativity surfaces in ordinary corridors too. A charged nurse strides thousands of steps through hospital wings each shift. 6 months later, her wristwatch lags behind the wall clock by slivers of time-only microseconds, but real. Every sprint down a hallway, every elevator rise, tugs her personal second, a breath longer than that of a still clock on a desk. Life thus weaves a hidden quilt of diverging ticks across our planet. Now travel to the dry air of the Atacama Desert, where astronomers guide the Event Horizon telescope. They aim at a black hole whose pull bends both space and time like molten glass. If a probe orbited the beast for just 1 hour by its pilot's reckoning, decades could pass for friends awaiting its return. Twin paradox stories in fiction draw from this stark truth: relativity is the geometry of space-time, not a metaphor. Close your eyes and feel the floor underfoot. At the equator, Earth spins east at close to half a kilometer every second, while our world races around the sun at roughly 30 kilometers per second. The sun itself carves a huge arc around the Milky Way at a speed that would cross the width of our planet in little more than half a minute. Your body rides all of these currents, and each layered motion subtly modulates the tempo inside your veins. Above you, the International Space Station loops Earth in about 90 minutes. Crew members age a few thousandths of a second less than those on the ground after half a year, and though they laugh at the effect, it remains measured fact. Their orbit lies high enough that gravity slackens, so the quartz oscillators and computers tick a shade faster than mission control clocks below. Docking codes include relativity corrections, so visiting ships meet the right hatch, not an empty portion of hull. Relativity also murmurs in your pocket. Your phone's map relies on 4 or more satellites. Each satellite's clock runs almost 40 microseconds ahead each day relative to one on Earth. Software subtracts that bias before your route appears. Without the fix, driving directions would misplace you by kilometers. Invisible arithmetic keeps you oriented. Einstein glimpsed these truths while working at a patent desk. He imagined lightning strikes at both ends of a train. To a conductor seated at center, the flashes seem simultaneous, yet to someone watching from a hill, they do not. That simple sketch dissolved the idea of absolute simultaneity and opened the door to special relativity. Years later, general relativity revealed that mass bends space-time, and with it, time itself, to test the idea. Two physicists once flew portable atomic clocks on commercial jets, one eastward, one westward, while a reference clock remained in Washington. After circling Earth, the airborne clocks disagreed with ground time by many tens of nanoseconds, just as theory predicted. Headlines celebrated a success that travelers never notice, yet every jet, train, and lift nudges its passengers fractionally off the universal beat. Deep minds prove the mirror effect. A clock several kilometers underground ticks slightly slower than one at the surface, its seconds crushed shorter by Earth's stronger pull. 60 years ago, two physicists in a Harvard tower measured a similar shift over a mere 20 meters. Using gamma rays that climbed a staircase, even small altitude changes tug on time with measurable force. Biology seems to respond. In high-plane villages, circadian hormones shift forward a hairbreadth compared with those at sea level. In deep basements, they retreat. Heart cells in Petri dishes beat at differing speeds when cultures are raised at different G-forces, hinting that timekeeping proteins listen to gravity's faint voice. Every machine obeys. Interferometers hunting gravitational waves adjust for altitude drift so that signals from merging black holes are not masked by earthbound curvature. Quantum engineers designing satellite networks plan to factor in gravitational redshift between twin photons, making encryption keys that carry spacetime signatures unique to each orbit. Night settles. Slip under your blanket, draw a long breath. Through the nose, feel air-cool alveoli. Your chest marks a local second, satellites overhead mark another, and somewhere a jet crossing the dateline marks yet a third. These rhythms form one cosmic orchestra playing in gentle disharmony, each instrument tuned by speed and altitude. Our story will next unravel the maths behind Lorentz transformation, then float around neutron stars, where seconds thin like taffy, and close examining optical lattice clocks, so precise they can feel the height of a bookshelf. Each chapter will flow without headings, so mind and dream may drift unbroken, as seconds drift in the sky. Lie back. Let the mattress hold you. Feel the pulse drum inside arteries, marking your personal time. Somewhere far above, a beacon blinks stronger where gravity is weak. Both songs blend into one silent score. Listen, and we begin slipping now from everyday streets into the thought laboratory, where the shape of time reveals itself with lines and symbols, yet never loses its quiet poetry. Begin by picturing two friends named Mira and Leo. They stand on a long, smooth highway at dawn. Myra boards a glider that will skim just under the speed of sound. Leo stays beside a roadside clock. Both wave goodbye. The instant the glider lifts, geometry takes over. Einstein framed that geometry with a set of stretch rules, called the Lorentz transformation. You can imagine it like tailoring cloth. The faster a frame moves, the more tightly the cloth of time must pull in one direction while letting space loosen elsewhere, so that the speed of light keeps its calm pace no matter who watches. In everyday units, the adjustment factor looks like the square root of 1 minus velocity squared over light speed squared. That dense fraction may seem aloof, yet all it does is fold one number, so light's own stride remains constant. Glider never approaches even a tiny slice of light speed, so the tailored second on her wrist ends only a few billionths longer than Leo's roadside second. But still, the sewing happens. If she flew long enough, and her flight were timed with a laboratory cesium clock, scientists would see the faint offset. During the famous Haffel-Keating flights, portable atom clocks on commercial jets drifted by roughly 200 nanoseconds, a sliver far smaller than a heartbeat, yet large enough for oscilloscope traces to show separate peaks. Why do such slivers matter? Because modern electronics dance on those scales. A smartphone processor toggles billions of times each second. Miss by a few hundred cycles and data packets misaligned, images tear, positioning fails. That is why the satellites guiding your walks send timing codes corrected for both orbital velocity and altitude. Each craft is higher than 30 circadian rhythms, stacked end to end. So gravity releases its tug, and their onboard seconds grow longer by a few dozen microbeats in a day. Their orbital speed shortens each beat by a smaller amount. The navigation chip in your pocket subtracts the tall mountain effect, adds the small speed effect, and the net residue is close to zero. Subtle balancing keeps the map still. Step into a research vault, where optical lattice clocks reside. Instead of cesium, they trap strontium atoms in a comb of laser light. Each atom flickering 8 quadrillion times per second, a rhythm sharp as a surgeon's scalpel. In such a clock, raising the entire apparatus by the thickness of a single coin lets its tick quicken enough to notice. That vertical shift is shorter than half a finger, yet gravity's gradient already tugs on time. These clocks now let geodesists map the exact rise and fall of continental plates by measuring the tempo difference between laboratories. Where once surveyors lugged tripods, today physicists listen to the music of passing seconds and convert tempo into height. Now imagine lifting that clock toward a neutron star. A neutron star packs 2 suns into a sphere not much wider than a large city, its gravity heavy enough to bend steel rails into spirals, were rails to exist there. Seconds near such an object slow to a crawl. Place that strontium clock on the crust, and its 8 quadrillion flickers would slump. Half of them lost to the squeeze of curved spacetime. From a distant perch you would see its red face dim and pulses lengthen like a throbbing drum heard through thick fog. Yet, to the physicist standing beside it, local processes stay calm. Chemistry unfolds, heartbeats keep pace, only visitors far away see the stretch. Relativity carries a gentle courtesy. It never troubles the traveler inside their own frame. Neutron stars are not mere curiosities. They serve as cosmic stopwatches for astronomers. Pulsars rapidly spinning neutron stars sweep radio beams across Earth, with accuracy rivaling atomic clocks. When those pulses arrive slightly late, teams know spacetime between us, and the star has flexed, perhaps nudged by gravitational waves rippling from distant mergers. Put another way, the star's slow seconds under intense gravity work in partnership with our faster seconds to build a cosmic interferometer as wide as the galaxy. Return to Earth and stand on a skyscraper roof. Set to identical wristwatches. Leave one on a lobby counter. Ride the elevator up. After a day, the rooftop watch will have pulled ahead by a handful of nanoseconds, the same drift that once puzzled early television engineers when broad CAST towers at mountain height fed signals to valley receivers. Those pioneer techs learned to insert small cable delays to line pictures back up before homes could see. Without realizing, they were apprentices of relativity. But relativity bends time not only with gravity and speed. It also interlocks energy and mass. Consider nuclear fusion, the process we aim to harness inside tokamaks, or superheated plasma loops behind magnetic fences. In each fusion event, a pinch of mass turns into pure light and heat. The lost mass is linked to energy through the same geometry that stretches time. The Lorentz factor hides inside that famous E=mc². Whenever fusion occurs, the seconds experienced by newly born photons differ from the seconds of the parent nuclei by just enough to keep C unchanged. Time dilation even shapes human biology in subtle corners. Jet-lagged travelers know subjective time can feel wrong when speed and altitude yank internal clocks forward or back. Molecular studies show that certain proteins, called clock genes, shift expression slightly earlier in airline crews who fly mostly west and slightly later in those who fly east, reflecting the 2 competing dilation influences: altitude, stretching seconds, ground speed compressing them. Long-haul pilots often train with light boxes and timed caffeine to nudge cellular timers back toward a midpoint. In essence, they perform a behavioral version of the GPS correction your phone manages by math. Light itself carries the record. Astronomers measure quasar light that has been traveling toward us since galaxies were young. On its multi-billion-year journey, expansion of the universe drags each photon's internal seconds so long that violet waves shift into radio murmur. When you tune an old shortwave dial and hear a quasar whisper, you are listening to seconds enormously stretched. Evidence of relativity painted across cosmic distance, like brush trails on ancient canvas, all around. Time keeps both secrets and promises. Your pulse sets the local beat, road traffic shakes your frame, satellites watch from above, and deep space watches in return. Each layer writes its own version of the same second, then hands it forward. Tonight, our path has traced the simple cloth of a stopwatch through laboratories, hospitals, deserts, and stars, yet we have not reached the deepest fold. Ahead, we will glide into practical rituals. How to craft a bedroom routine that acknowledges your personal time gradient. Why lying flat, or inclining head and legs, influences blood flow and brain clearance, in part because of subtle, relativistic pressure differences. And how to use slow breathing to synchronize internal oscillators with the macro pulse of Earth's rotation, so you wake centered in both body and cosmic clock. Feel the weight of your blanket settling. The floor hums with distant traffic slowed by its own mass. Satellites sweep overhead, their seconds already longer than yours. And countless atoms inside your chest count beats matched to nothing but the curve of space-time cradling this planet. Breathe once more and notice how that single breath takes a little longer now than it did at the moment you pressed play. Stretched by your heartbeat, by Earth's spin, by the wandering of galaxies. In the soft dark between inhalation and exhalation. Listen, this is the longest second, and it belongs entirely to you. Your bedroom building on the elastic seconds we explored a moment ago can serve as a miniature space-time lab, quiet, dim, and arranged, so every heartbeat drifts through moments a touch wider than those demanded by the daytime rush. Lift the head of your mattress, only the thickness of a slim paperback, and feel how even that gentle incline lets venous blood glide home with less strain, easing the brain's nightly watch. Neuroimagers who monitor volunteers on inclined beds report delta rhythms deepen and glymphatic flow climbs by several %. Figures small in a datasheet, yet large enough that after a few dozen dawns, the volunteers reach for coffee. A little later, or not at all. Next slide, a rolled towel beneath your calves, so legs rest just above hip line. Baroceptors in the neck sense the extra central volume, and the medulla hushes heart pace by 2 quiet beats. Those recovered beats lengthen each local second experienced by heart cells, giving arteries a micropause between pressure crests. When cardiology teams track the habit over 6 weeks, resting pulse dips roughly 5 beats per minute. That whisper of change spares tens of thousands of contractions every month, so the myocardium has more downtime to repair collagen and clear oxidants. Now treat light as a malleable tide, rather than snapping lamps off like a stage curtain. Fade illumination in 3 broad waves. Keep a mellow cafe glow for late messaging. Slide to campfire amber while brushing teeth. Finish at ember red when you slip beneath the quilt. Melatonin then rises, like tide not flood, aligning mind and body. Together with night. Wrist-mounted spectrometers show that this sliding glow can advance. Internal lights out nearly 45 minutes, compared with an instant blackout. Add 30 nights together, and you reclaim an entire day of extra slow-wave restoration. Without touching an alarm setting, sound deserves an equally gentle slope. A sudden vacuum can jolt the limbic watchman trained by evolution to treat sharp silence as ambush. Keep one sonic anchor in the room, maybe the low drone of a fan, or the faint heartbeat of a bass tone, softer than a whisper. Engineers at deep space. Antenna sites first noticed the effect when technicians slept better next to steady coolant pumps than on nights the pumps cycled off. Motion sensors confirmed fewer midnight jolts whenever at least one constant ribbon of sound remained. Breath is the lever under complete conscious command. Shape it so the exhale lingers. 5 counts in, rest 1 beat, 7 counts out. Exhalation activates the vagus nerve, tilting autonomic balance toward rest. Infrared plethysmographs strapped to yoga veterans prove that, once ingrained, the lungs keep the slower music all night, and slow waves settle as even swells. Instead of scattered peaks, layer these habits, and you create a ritual that bends seconds, just as orbital velocity bends satellite clocks. Cardiologists following sleepers who adopt all 5 adjustments incline. CALF. Rise, light slope, anchored hum, slower breath log, resting heart drops of 5 beats after 2 months. Those 5 quiet beats may appear trivial, yet they compound, like interest. Gifting the heart extra pause to phosphorylate. Energy stores between pulses, and lengthening its service life in the background. Relativity echoes in the details. Astronauts above Earth raise salt intake because fluids rush headward. Your mild pillow tilt mimics that shift, and kidneys respond by scheduling fewer nighttime trips. Sleep diaries note about 1/3 fewer bathroom visits. Once a simple 5-degree incline becomes habit, leaving slow-wave blocks unbroken. So hippocampal circuits complete their nightly file transfer from short-term clutter to long-term library. Memory rewards the routine. In lab mazes, rodents exposed to gradual light fades and mild incline store routes in half the trials needed by controls. Language students rehearsing vocabulary under the same ritual recall several extra lines next dawn. Margins appear, slim single digits here, a tranche of delta. There yet those deltas stack semester over semester until whole chapters stay learned without re-cramming. Electronics obey the same principles. Satellite engineers learned that lithium cells near jittery reaction wheels aged faster. Microshakes micro-scratched electrodes. In bedrooms, rattling pipes jar brain tissue and a gentler echo. Choose a steady fan tone over a clanging radiator, and both your neurons and your phone battery will enjoy a quieter life. Morning should mirror evening slopes in reverse. Lift blinds halfway. Let daylight bloom across 5 slow breaths. Keep the fan humming until you sit upright, then fade it. Stand briefly on tiptoe so calves send blood downward, reaffirming gravity's daytime direction. SIP. Water cool, not icy, nudging hypothalamus to wake metabolism without triggering a cortisol jolt. Try adopting one variable tonight, maybe the pillow incline. Add breath pacing tomorrow. Track wake-ups, hunger surges, and afternoon yawns. Patterns will stand out as plainly as satellite ephemerides, showing you can widen personal seconds beneath an ordinary duvet. Soon you may notice strange graces. Knees creak less when walking stairs. Eyelids open sooner behind dawn light. Dream fragments linger long enough to jot down. Expand the ritual further if curiosity calls. Replace overhead bulbs with tunable LEDs so color temperature slides on a 10-minute track. Set a narrowband noise generator to fade by a single decibel every quarter hour until it rests just above hearing. Swap a stiff pillow for memory foam so neck vessels stay aligned, trimming the micro efforts of each beat. Line curtains with blackout cloth, yet leave one fingertip gap so dawn arrives in a ribbon, not a spear. Every tweak adds another strand to a net that cradles the nervous system. Physicists would call such layering. Superposition multiple small shifts, producing a single, elegant outcome. Your body feels the result as a night where the transition between thought and dream blurs. Sleep becomes less a plunge into darkness, more a gliding spiral ramp, guided by gravity, breath, and light working in accord. Between inhalation and exhalation, listen well. Satellites flash and tick faster. Deep sea cables pulse slower. Distant pulsars count long spin cycles across cosmic dusk. Yet all belong to the same elastic tapestry. When you bend seconds in your favor, the mind no longer falls asleep, sails there. Born on currents, you now know how to shape. Asterisk, asterisk, drifting further outward from the comfort of your own bed. Picture a lone research vessel coasting through deep space, its hull wrapped in graphite composites instead of quilted blankets. Its crew enclosed in a silence so complete that each breath sounds like distant surf. The ship's trajectory curves toward a region astronomers call the gravitational well of a supermassive black hole. Out here, every rule about seconds and minutes bends in extreme ways, giving scientists a natural laboratory far more dramatic than an inclined mattress or a dimming lamp. The closer the craft glides to the dark sphere, the more sharply time itself stretches, turning nearby heartbeats into lazy drumstrokes, while clocks back on Earth race ahead. Mission planners know the danger of falling too deep into that well, so they choreograph a sweeping arc called a parking orbit. At this safe distance, tidal forces still allow metal to keep its shape. Even here, however, an onboard clock will lag behind Earth's clocks by entire minutes over just a few weeks. Engineers program the ship's computer to adjust for the drift each midnight cycle. Otherwise, transmitted data packets would arrive back home, stamped with timestamps that no radio telescope could reconcile. Inside the vessel's dim control room, an astronaut named Aria logs the difference. She grows fascinated by the sensation that her voice messages take longer to return than they should. She records daily journals on a wrist recorder, noting how her thought rhythms feel unhurried, almost syrup-like. Her colleague Matteo, whose temperament is naturally brisk, surprises himself by adopting slower speech patterns. As though the stretched seconds outside the hull have seeped into neurochemistry. The crew's medical officer monitors dopamine and serotonin rhythms and discovers they drift in a pattern never observed on Earth. Neurotransmitter cycles lengthen, likely because the suprachiasmatic nucleus, that tiny brain clock, is entrained not only by light cues, but by the subtle curve of local spacioterum, back on Earth. A team in the Alps coordinates a simultaneous ground experiment. Volunteers live in an underground habitat shielded from daylight. Their environment remains steady, at a gentle twilight glow, and they follow a simple routine. Read, meditate, record dreams. Yet despite identical conditions, the cave clock never stretches as much as the spaceship clock, proving again that gravity's pull, not mere isolation, sculpts the pace of seconds to connect the two living experiments. Researchers stream a shared soundscape and ocean swell that rises and falls once every half minute. In the cave, it remains a comforting metronome. But on board the ship, the same patch of audio lengthens imperceptibly, drifting out of phase over days. Arya remarks that the swell seems to take a breath between each crest, something she swears wasn't present during the first playback. Data confirms her perception. The ship's local time adds 1 part in a few billion relative to Earth every second. Enough that a half-minute audio loop widens by noticeable fractions after weeks. Project managers send a package of reading material about ancient monastic timekeeping methods to help the crew anchor their sense of day. Monks of the 9th century had relied on candle clocks' beeswax columns, scored with rings that burned down in equal steps. The flight crew, 40,000 light seconds away, improvised their own version, slicing sticks of biodegradable polymer into equal lengths, each with a single filament that glows when ignited. They light one at the start of every shift, glad for an object whose burn rate reacts to local physics. The candles last just a little longer out there than they would in alpine air, proving again that even flame obeys time's gentle stretch. Meanwhile, students at an urban university participate by constructing tabletop replicas of optical lattice clocks, trapping strontium atoms with intersecting beams. They raise one instrument on a stack of textbooks, leave its twin on the lab bench, and stream their ticks to classmates via fiber line. Over a weekend, the elevated clock gains microseconds, barely enough to register, but enough to remind each student that their own steps between dorm and classroom pull them through shallow gradients of time. All 3 branches of the cave campus meet every fortnight for a live call. Communication delays remind the team that even photons need time to cross the growing gulf. Conference participants speak slowly, pausing for echoes. Students impatient at first soon find the rhythm meditative. They begin to fill the waiting pockets with short breathing routines taught by the yoga-inspired pattern you practiced earlier. Exhale longer than inhale. Let the radio silence become a collective pause. In that hush, everyone senses spaced elasticity not as a cold equation but as a feeling, almost a breeze, brushing the skin of consciousness, somewhere between orbiting black hole and valley schoolyard. A mother rocks her infant at 2 a.m. The child's sleepy brain has its own dilation trick. Newborn REM cycles happen twice as often as those of adults, compressing neural housekeeping into power naps so growth can gallop ahead. Relativity inside the crib thus mirrors relativity. Among stars, seconds alter their weight, depending on the purpose they serve. Whether laying down memory proteins or safeguarding a vessel's trajectory, the wider science community embraces the ongoing study. Climatologists realize satellite cloud images must be time-corrected when satellites drift higher after orbital boosts. Stock market quants discover that transcontinental fiber cables require picosecond adjustments to prevent high-frequency trades from misordering. Even violin makers become curious, attending a lecture where they learn that spruce wood ages differently at high mountain altitude, because slower cosmic ray bombardment adds faint isotopic tweaks over decades. For Arya and Matteo, the most profound moment arrives near mission's end. Mission Control instructs them to nudge their craft slightly closer to the event horizon to test a new sensor array. After the short burn, they run a diagnostic. Onboard watches now gain whole milliseconds per hour relative to ground clocks. For one shift, the crew decide to turn off corrective algorithms and live entirely by local time. The decision is safe, but deeply felt. Meals arrive later than the circadian stomach expects. Computer prompts wait that little bit longer before blinking. Aria lies awake, feeling each heartbeat stretch like warm taffy. She reports a sense of floating around her own thoughts, as though mental edges soften. Matteo writes a poem describing stars that blink in elongated syllables. Overnight, the ship completes a single orbit of the black hole's outer fringes. And dawn, if one can call it dawn, arrives as a blue halo on the horizon of darkness. When they restore synchronization the following morning, the crew discover their 8-hour rest period lasted roughly 10 Earth hours, yet they feel no jet lag. Time dilation, and serving them like a slow lullaby, delivered more sleep cycles within the same personal span. Mission psychologists receive the logs and conclude that relativistic rest could teach insomniacs a thing or two about perceived versus measured night length. Eventually, the vessel fires engines and climbs outward, trading stretched seconds for Earth normal pace. As seconds shrink, the crew now find tasks rushing by. Systems checks finish before the mind registers. Conversation seems quickened, brisk. Each astronaut pens a summary for neuroscientists. Returning to faster time feels like stepping onto a moving walkway pointed in the opposite direction. Muscles must refamiliarize themselves with impulse timing. Yet within a week, baseline circadian markers settle. Kidneys flush, excess fluid, and neurotransmitter rhythms slide back toward terrestrial patterns. Back in the cave, volunteers finish their own quiet retreat. Their internal clocks lengthen too, but through social isolation rather than gravity. They discover that without sunrise cues, personal day length expands by roughly 40 minutes, matching classic bunker studies yet offering modern proof that slow-wave sleep remains consistent even when subjective calendar flips. The campus students, flush with data, write code to overlay their clock drift on a 3D model of tectonic uplift. They see local topography as a heat map of tempo. Mountain ridges tinted crimson for faster seconds, river valleys shaded indigo for slower ones. For fun, they simulate what would happen if they moved their clocks to the roof of the tallest tower in town and, with one tick shift, overlay it on bus route timetables. The plot reveals tiny but real schedule offsets, explaining at least a fraction of why GP synced arrival boards sometimes drift from reality on high-altitude suburban lines. Every layer of the experiment, from orbital path to bedroom breath, now feeds a global database. Researchers note patterns. Incline pillows accelerate lymphatic flow, mostly in people over 30. Sloping light benefits those whose evening cortisol curves spike late. Anchored hum reduces midnight spikes across age groups. Analysts propose a personalized sleep dilation score, combining altitude, mattress angle, bedtime audio, and breath pace. They envision bedside apps that suggest microadjustments. Raise head 2 millimeters tonight. Pause. Exhale 1 heartbeat. Longer? The aim is not to imitate astronauts but to build a civilian relativity seconds, tailored gently until dawn. And so the journey that began with cesium atoms ends by refining lullabies. Between your inhale and exhale, somewhere a neutron star squeezes time thin. Somewhere an infant expands it in dreams. Somewhere a pocket watch in a museum ticks in amber seconds, preserved by steady gravity and polished brass. All of them belong to the same elastic tapestry, and tonight, as you settle onto your modest incline, you join the orchestra playing that infinitely adjustable score. Beyond the laboratory networks and the star-skimming ship, imagine an entire city quietly redesigned around the subtle bend of time. Engineers call the concept chronotecture buildings, and services laid out so the microseconds gained or lost by altitude, traffic flow, and electromagnetic chatter all lean in favor of human rest and long-term health. The pilot project rises on high desert ground, where air is thin, daylight hard, and nights spangled with unfiltered starlight. Architects raise residential towers on terraced slopes, each floor stepped back so every bedroom window rests a few meters higher than the one below. That gentle climb alone gifts upper residents nanoseconds of longer nights, each year imperceptible moment to moment. Yet enough over decades to shave stress hormones by tiny but cumulative margins. City transit. glides on magnetic cushions, set just below street grade. Each carriage coasts faster than surface traffic, yet remains whisper quiet. And designers program onboard lighting to dim by 30%, while the train tunnels beneath a ridge, acknowledging the slight increase in gravitational pull and compensating by stretching passengers' subjective seconds with amber glow and subdued engine hum. Even elevator shafts are tuned. Locally sourced basalt counterweights and low-jerk motors accelerate so smoothly that inner-ear sensors never jolt. And in those calm vertical journeys, the blood's pulse echoes the elevator's glide, reinforcing the body's internal metronome rather than contesting it. Hospitals in this chronotect city place intensive care wards on mid-levels, not the ground, where seismic noise vibrates bed frames, nor the penthouse heights, where low-pressure taxes, lungs, midway, clocks, and capillaries find a balance. Ventilation ducts produce a consistent low purr. Recovery rooms dim along a 90-minute curve, mapping the station orbit we visited in Part 4. So patients subconsciously align with an astronaut's restful, sinuous cycle, a slow high delta wave, followed by a gently lifted theta plateau. Monitors display both heart rate and temporal drift, a live value that predicts when the patient's internal time curve will peak in readiness for physiotherapy or medication. Schools adopt the same logic. Morning math lessons sit on first and second floors, where seconds run a whisper slower students. Alertness peaks with the heavier gravity and brighter light. Music and creative writing happen upstairs in loft rooms bathed in skylight. Here, stretched microseconds soften the critical inner voice and invite playful, rhythmic exploration. Teachers consult a schedule that factors solar elevation, predicted barometric swings, and even the city's faint tectonic breathing plate movements, measured by strontium lattice clocks in underground basements. Industry follows suit. Firms bury server farms in cooled caverns where milliseconds accumulate under extra rock. Mass advantageous for certain arbitrage algorithms that thrive on stable, slower ticks. Meanwhile, biotech greenhouses ride on the raised riverfront terraces. Chloroplasts apparently favor the fractionally longer photon interval up there. Tomatoes grown at the terrace crest show thicker cell walls, keeping freshness through the shipping chain. Taste panels claim the fruit feels as though each bite elongates, a slow flavor bloom compared to their valley floor cousins. Yet the city's planners reserve one district untouched by chronotech theory, the agora of equal seconds, a park sunken into the very center at average altitude. Here gearheads, artists, and skeptics gather to test whether the chronotect concept is science, placebo, or art. On weekends, lab technicians wheel in portable lattice clocks and run public demos. Slight yet repeatable drifts appear as they raise the device onto a granite plinth. Children cheer. Elders ask if the extra nanoseconds can be banked like coins. Volunteers lie on inclined park benches, practicing the long exhale breathing you mastered in earlier parts. Electrodes on their temples. Project slow wave readings onto giant lanterns hanging between cedar posts, glowing brighter as synchrony deepens. Skeptics concede that their heart rhythms settle when the lanterns show green. Whether or not the time warp math convinces them, all these civic experiments feed into a new branch of chronobiology. Researchers cross-reference blood panels from commuters, ground floor shopkeepers, top floor gardeners. They discover faint signatures, telomeres eroding a little slower in rooftop custodians. Platelet aggregation reduced by small but measurable margins in basement librarians. A global symposium convenes in the same desert city. Delegates from polar research bases share data showing that crew deep in ice tunnels sleep with fewer waking microarousals, once chamber slopes, low hum, and gradual lights replicate the desert. Apartments recipe. Oceanic drilling engineers reveal that during month-long shifts on sea platforms, a mild head tilt pillow cuts caffeine dependency by 20%, echoing the kidney response logged in the orbital crew of Part 4. Meanwhile, time dilation leaves its mark on culture. Local poets craft nanosecond haiku. 3 lines paced by a handheld optical tick box. Press once. Pause for 9 billion cycles. Press again. Their verses celebrate the almost silence between photons. Street musicians tune steel drums to a concert, pitch calibrated at rooftop chronorate, then busk downstairs. Passers-by describe the melody as warm and unhurried. Though a frequency meter shows only fractional deviation from standard pitch, citizens adopt micro-rituals. Some angle their smartphone screens 5 degrees off horizontal during late-night browsing, claiming it calms the scroll impulse. Others program smart bulbs to fade not in minutes but in hertz, stepping brightness after every 90 million quadrillion photon hits. Neighborhood bakeries advertise time-raised sourdough that proofs on rotating racks. Spending half an hour at basement gravity, half on attic breezecrumb texture, gains an almost imperceptible elasticity. Critics emerge, branding the movement chrono-elitarian. Why should top floors earn longer telomeres? City Council responds by installing vertical equalizer hubs. Tiny lifts with plush recliners that glide residents through 12 stories in a slow sinusoidal loop, granting everyone shared exposure to both faster and slower seconds for a brief, meditative ride. Passengers report dreamy flashes akin to micronaps, no longer than 2 real minutes, yet leaving a sense of extended pause at the university's biomechanics wing. Scholars test ultra-slow resistance training. Participants perform a single squat, lasting 20 seconds downward, 20 upward. Motion capture reveals muscle fibers recruit differently under stretched, perceived seconds, generating less lactic burn, yet similar strength gains. One thesis argues that such training synchronizes with local building drift by performing sets on a mid-level floor. Athletes ride the sweet spot where muscle calibration, light slope, and audio hum unite. Even city lighting engineers join in, switching traffic signals not strictly by flow, but by circadian forecast. When solar storms near Earth pulse geomagnetic fields, microsecond corrections ripple through the grid to avoid undue lag between GPS and ground controllers. Drivers never notice, yet congestion models show smoother clearing during geomagnetic peaks. While chronotech blossoms, cosmologists remind citizens that these gentle Earth-scale tweaks pale beside true cosmic stretches. They stream nightly lectures into cafe domes, displaying simulations of galaxy mergers, slowing time thousands-fold along tidal tails. Visitors watch neon webs glow on ceiling screens while sipping tea that steeps an extra minute to mimic a longer Martian second. They leave with a new humility, even at peak chronotech precision. Human tinkering dips only toe tips into relativity's ocean. One dusk. Araya, the astronaut now back on Earth, tours the city, invited to inaugurate an exhibit titled Relativity. At home, she stands on a balcony planted with low-noise fans, dim stone lanterns, and adjustable incline hammocks. She speaks softly. Out there, time pulled my thoughts like taffy. Here, you've braided that pull into daily rhythm. Mateo, present via HoloLink from a lunar construction site, adds that on the moon. Seconds drift a bit quicker, and lunar habitats have begun adopting the desert city's light slopes in reverse brighten. Not dim, before rest, sinking brain. Chemistry with a lighter lunar pull. The exhibit ends with a fountain whose water ascends, glass helixes, pumped just high enough for droplets at the top to fall fractionally slower, shimmer longer in lead starlight, then splash into a basin where sensors play sub-bass tones matching the drips. Visitors rest on sandstone benches, breathe long exhales, and feel the seconds collect like gentle rain on moss. Some claim they sense a faint stretching in their bones. Others simply enjoy the quiet. And so the chronotech experiment matures. A city tuned to microdilations, a population sleeping deeper, batteries lasting longer, databases enriched with nanosecond fingerprints. What began as a curiosity about cesium ticks and mountain clocks has unfolded into architecture, agriculture, even poetry. As night drapes the desert skyline, rooftops glow in ember red, fans murmur, and tens of thousands of mattresses lift, heads by a single paperbacks, high-teach resident, floating toward sleep on a personal ribbon of lengthened moments. The universe may keep its black hole extremes, but here, amid terraces and sand, humanity claims a gentler mastery, the art of tailoring time into the quiet garment of rest. Fresh research MRI suites glow with soft blue light as neuroscientists gather to chart what silence, altered gravity, and chronotech surroundings carve into the living brain. They no longer hunt single regions that blink on or off. Instead, they Trace entire constellations networks that brighten, sink, and dim in slow rolling patterns, more like ocean tides than blinking bulbs. Two names hold most attention: the default mode network and the salience network. The first hums when attention drifts inward, weaving memory with imagination. The second snaps awake to rank external and internal signals by urgency. Together, they conduct the symphony of daydream and focus, lullaby and alarm. Researchers invite volunteers from the desert Chronotech city. Some sleep on low floors, others in high terrace lofts, a control group in the agora of equal seconds. Scan sessions begin close to dawn. Participants glide into scanners, still wrapped in drowsy haze, eyes closed, breathing slow. The machine's low rumble sets a constant bass, hum, much like the anchored sound we placed beside your pillow. As magnetic gradients cycle, images bloom on adjacent monitors. Technicians watch neuronal ripples move across cortex sheets in slow waves, colored overlays revealing blood's quiet dance. Patterns diverge by altitude. Loft sleepers show slightly longer pulses of synchronized activity in the default mode arches that reach from midline frontal lobe to posterior cingulate. Their seconds stretch, not only on paper it seems, but across microvascular timing. Meanwhile, ground floor residents display brisker, more segmented bursts, useful perhaps for midday alertness, but less ideal for unbroken dream segments. The finding echoes earlier mouse maze studies. Even faint gravitational gradients edit how neurons cascade into nightly replay to examine salience. The team pipes gentle, unexpected tones through soft earbuds, a chime, resembling distant wind bells. High loft volunteers barely ripple. Their salience networks lift only a quiet eyebrow, then slide back toward default hum. Those from mid-levels show moderate spike and smooth return. Ground floor sleepers jolt slightly higher. No group appears stressed, yet the amplitude gradient is clear, with fewer external startles during sleep. The salience system appears to downshift baseline vigilance. Next, scanners. Welcome seasoned astronauts now living on Earth again. Months have passed since they re-entered faster planetary seconds, yet subtleties remain. Their insula nodes, key hubs bridging body signals to conscious feeling, still fire in languid arcs rather than stiff peaks. One physician jokes that their brains carry a souvenir time stamp from the black hole trek. Cognitive tests confirm. Astronauts score marginally higher on tasks, demanding broad context but still stumble on rapid serial calculations until a coffee dose nudges them back to terrestrial tempo. Curious about these findings, the team builds a miniature time dome inside the lab. The room dims by degrees. Fans project a steady hum. Mattress platforms tilt a modest angle. Air pressure rises to simulate a valley basin. Inside the dome, novices practice the long exhale breathing you know well. After only 40 minutes, fMRI reveals a telltale slide. Default mode flood pulses lengthen and smooth. Salience peaks shrink. Blood work drawn before and after shows cortisol dipping, dopamine edging upward. But most striking is a subtle increase in brain-derived neurotrophic factor, the molecule that helps synapses sprout new shoots. One researcher whispers that the dome feels like giving the cortex a warm bath. Data alone cannot capture subjective drift, so volunteers record audio diaries. Many describe a softened edge between inner thought and senses, as though the border fence turned low hedge. One recounts revisiting an old memory of climbing peach trees. Another says random office anxieties floated past like leaves without latching. Scholars of contemplative traditions recognize the description. Centuries-old meditation manuals tell of turning the mind porous, so thought, like light through rice paper, glows, yet does not blare. Intrigued, the group recruits experienced Zen practitioners, Benedictine monks, Sufi dervishes, and Himalayan yogis for a cross-practice scan. Regardless of tradition, when breath slows, posture settles, and surrounding sound drops, their default mode blossoms into wide, even waves. Salience flickers, but never yanks. Meanwhile, a third network, often dubbed the executive control loop, steps softly into the weave, ready to guide intention without harsh push. The triad forms a braided braid. Default mode supplies imagery. Salience tags gentle priority, executive loop shapes, direction. Together they build a dream pathway one can walk while awake. By comparing thousands of scans, analysts craft a tempo index, a ratio describing how long each network holds synchrony before passing the baton. In insomniacs, the baton exchange is frantic default pulses, chop salience, spikes executive control, barges in to worry. After 8 weeks of chronotect rutina, mild incline, tuned light slope, anchored hum tempo index shifts toward the meditative sweet spot, even in those chronic night wrestlers. Sleep diaries echo the number. Wake after sleep onset minutes drop nearly by half, while scanners hum. Cellular studies unfold 2 floors down. Brain organoids, tiny pinhead clumps of human neurons grown in gel, rest inside miniature centrifuges that tweak local gravity fractionally by spinning chambers slower or faster. Some organoid cohorts bathe in timed LED cycles mimicking desert sunset fades. Others sit in abrupt dark after several weeks. Electrophysiologists record slow calcium waves prowling across organoids exposed to gentle slopes, but in abrupt dark controls, waves appear frenetic. Genetics teams sample RNA and find upswing in genes controlling GABA receptor subunits molecules, vital for calm inhibition. The implication: even brain tissue without lungs, blood, or thoughts responds to softened environmental pacing. Back in the chronotect city, clinicians translate lab findings into therapy pods scattered through public libraries. Visitors, free of charge, recline on mild incline couches inside whispered quiet capsules. Overhead LEDs glide from pearl to ember over 20 minutes, while fan hum fills the chamber. Sessions last half an hour. Entry surveys flagged high acute stress. Exit surveys show mood relief, comparable to short walks in forest parks. Biometrics collected by fingertip sensors confirm modest heart rate variability gain. But the real surprise is retention. Patrons return weekly, reporting deeper evening sleep without having changed diet or workload. The pod becomes urban forest for those who can't leave town. Industry eyes wider applications. Semiconductor fabs experiment with lull bays break rooms, tuned like the lab dome, hoping microsleep resets cut error rates on delicate linography lines. Airline alliances test recliner designs that embed slight pelvis up tilt and broadband drone. Early passengers rave about time bubble naps that leave them less groggy on landing. Streaming platforms even pilot dynamic dimming that eases screen luminance across an episode's final act, whispering the cortex toward bedtime rather than jolting it with credits glare. Skeptics raise eyebrows. They argue placebo can mimic many findings. Perhaps mere novelty soothes volunteers. Researchers answer with blind crossovers. Some pods invert slopes or modulate noise in jagged bursts. Participant bodies notice. Heart variability falls instead. Of rising EEG shows micro arousals. The subtle architecture works only when slopes, hum, light, and breath align into a single downhill ramp. Echoing the spacecraft dawn cycle, or the hillside terraced bedrooms. Across conference halls, debate shifts. Not weather environment shapes neural tempo, but how fine-grained we can tailor it before returns diminish. Some propose ambient scripts. Short climate loops, custom-fitted by wearable sensors res pillow. An extra finger's width tonight, shift lamp fade, 2 minutes earlier. Others warn of overtuning, comparing it to monoculture farming, healthy. Ecosystems need drift, minor storm, and lull. Else resilience fades. Researchers therefore design tempo mosaics, weekly patterns that sprinkle gentle deviations, one night of cooler light, one night of ocean hush instead of fan drone, one afternoon siesta in a hammock angled steeper than usual. Over 12 weeks, volunteers following the mosaic sustain benefits without adaptation plateau. Brain scans show tempo index holding steady at the meditative sweet spot rather than sliding back as in constant routine groups. Even sports science joins the dialogue. Coaches track recovery in cyclists sleeping on mild incline the night after mountain stages. Blood biomarkers of muscle repair climb higher compared with flatbed control nights. Athletes say legs throb less on waking. A new training manual emerges. Ride high climbs. Then sleep with head raised gradient to mimic vascular flow in the climb's low-gravity illusion, thus flushing metabolites faster. Schools adapt mosaic logic. Monday maths in brisk ground-level classrooms. Wednesday creative arts in rooftop studios. Friday debates in mid-level amphitheaters with slow light dimmers. Students move through time gradients like swimmers crossing currents, synchronizing internal clocks to shifting challenges. Early metrics indicate fewer afternoon slumps and a gentle rise in retention scores, suggesting polyrhythmic academic pacing may outshine old bell schedules. As findings ripple, the Chronotect City Host Committee drafts a charter declaring time a civic resource. They pledge to retain dark sky ordinances, low rumble infrastructure, terraces that slope light, and public pods for those whose apartments lack incline. Citizens celebrate with a festival of lantern drones choreographed to ascend from valley. Floor 2 rooftop zenith, each string glowing fractionally slower as altitude climbs, painting stratified halos of elongating moments around the skyline. Under those rings of warm light, you might stroll, lit faintly by a dusk that breathes in extended seconds. Stop and inhale. Your lungs accept air cooled by desert night. Blood rises smoothly toward brain. Salience rests. Default mode opens wide. Somewhere a satellite ticks faster. Somewhere a downtown battery ages slower. Somewhere a piece of code, adjusting train doors, leans on picosecond corrections. All these separate pulses and paces share the same organism. Space-time, alive with gentle flex, inviting listeners to tune. When you return home, incline your pillow, lower the lamp in 3 slow waves. Breathe out longer than you breathe in, and you will feel the city's huge mosaic fold into the quiet chamber of your skull. A hush shaped by science, yet echoing ancient monastic calm. Tomorrow morning, seconds will speed up again, schedules will tighten, but a residue of widened moments will remain soft resilience inside your neurons. You have joined the constellation of brains learning to sail rather than stumble through the elastic river of time. Inside a terrace tower designed for human time experiments, 7 volunteers slip on green pulsing biosensor cuffs and open well-worn notebooks. Their task is simple to state and intricate to perform. Spend an entire week living inside deliberately. Stretched moments, soft mattress tilts, sunset slow lamps, faint anchored hum, long exhale breathing, then record every ripple in concentration, emotion, and dream. The building itself is a precision instrument. Oak floors floated on shock pads, honeycomb cork within walls, magnetically isolated ceilings, and in the basement a cesium beacon that ticks an unerring master beat through fiber branching to every loft. At first light on Sunday, the beacon synchronizes the cuffs and the experiment begins. Mara, a virtual reality artist, is the first to rearrange her habitat. She slides a paperback under the bed's headboard, folds a cotton roll beneath her calves, dials her desk lamp to a mellow cafe amber, and settles a small box fan until its hush resembles distant surf. 12 hours later, reviewing stylus data from her tablet, she finds unbroken oak branch curves where she once drew jittery hieroglyphs. Heart rate variability rises a gentle 8%. A skin surface EEG, patch notes an early delta might. During a 10-minute EIS closed pause that afternoon, Eduardo spends Monday recovering from a hospital night shift. He feeds faint brown noise through foam earbuds. Pager alarms still yank him from naps, yet salience spikes collapse within moments. When the hum returns, recovery time is half his baseline. He writes in his log that hallway sirens now feel like ripples rather than waves, and sensor traces confirm the feeling. Vagal tone, once sought boothed, smooths into rolling hills. Tuesday ushers in twin experimentation. Hannah inclines her mattress 5 degrees, while Leela keeps her bed flat, but sets her ceiling lids to fade across 90 minutes. Blood draws at breakfast show. Leela's melatonin crest, arriving 40 minutes sooner, whereas Hannah's cerebrosplymphatic markers jump for percent evidence that tilt favors brainwashing while light slope shifts inner dusk. They trade setups that night, and the metrics swap sides. A mere demonstration that physics, not personal quirk, drives the shift by Wednesday. Software engineer Ravi has woven long exhale breathing into his debug routine. 5 counts in. Brief pause. 8 counts out, again and again while code compiles. Error tallies slump by a fifth. That night, polysomnography records his longest continuous delta shelf 23. Drowsy minute sand, his cuff clocks a slight upward curve, in local second length. A rooftop tempo though, he sleeps mid-floor. Midweek silence comes on Thursday. Inside a cork-lined vault no larger than a freight container. The room's air arrives through laminar vents below hearing. No fan runs, no device blinks. For 10 minutes, silver whistles bloom phantom tones from auditory. Autogain, then fade until pulse and breath are the only tides. Brain overlays reveal default mode bays, spreading wide and salience ridges sinking. Upon exiting, elevator bells feel thunderous even though the same decibel meters show typical city hush. Thresholds have simply recalibrated downward. Friday becomes a field test. Each participant pockets a single anchor. Mara carries a pebble-sized halo lamp that drifts through sunset colors. Eduardo his brown noise loop, Ravi a haptic ring that cues breath pacing. The twins slim pillow wedges, while Omar the control. Observer relies on attention alone. Through subways and offices, Slack threads and cafe counters, micro-errors fall where anchors ride shotgun. Omar alone notes sharper horns and a heavier afternoon drag. EEG ear clips worn by commuters show salience peaks flatten whenever an anchor hums or glows. Saturday night crowns the mosaic. The team meet in the Zenith Suite, 40 meters above Plaza Stone. Dinner cools to skin temperature, stoneware. Forks muffled by fools, stone handles. Lamps drift from apricot to ember, fans settle into a two-blade murmur, timed to heartbeats. Mattresses lift calves, a handspan, noses draw the 5/8 breath. Data streamed wirelessly reveals slow-wave trenches approaching 40 minutes for several sleepers, brain-derived neurotrophic factor, up by a fifth. Cortisol tracing an effortless childhood arc toward dawn. When sunrise bleeds into loft windows, cuffs flash teal, heart rate variability peaks. Skin temperature curves gentle, clock drift ribbons form tiny. Parabolas largest on tilt, nights hinting at micro-stretched seconds. Aggregated across a wall-length display. The week resembles a meteorology of mind. Red salient storms shrink each day. Blue default mode, seas widen. Green executive currents thread calmly between a solitary meteor, Skarmara's upstairs neighbor, dragging furniture at 2114. On Tuesday shows recovery, twice as fast as her. Pre-study profile. Suggesting the layered regimen installs shock absorbers beneath neural tempo. Outside laboratory walls the city listens. Street kiosks stream anonymized heat maps. Commuters pause, watching crimson shrink to rose. Reservations for public silence pods triple. Elevator panels flash brief quiet tide prompts, coaxing riders to lengthen one exhale before doors. Part. Even cafes retune playlists, jazz paced at 20 beats per minute downstairs. Ambient drones, 5 beats slower on terraces 2, align with altitude's faint clock, peer review. Preprints tumble, out micro-altitude gradients extending. Default mode, coherence. Anchored hum damping. Autonomic reactivity. Graceful light fade advancing melatonin, without filtering the spectrum. A field takes shape. Homochronomics. Studying how small environmental levers and the behavior they invite widen subjective seconds, without drugs or elaborate technology. Intensive care wards test pillow tilts. Libraries hang hourglass. Luminaires that dim grain by grain. Marathon coaches add mid-race hum retreats to slow cardiac drift. Blind swap trials with inverted slopes and jagged noise bursts, CHRV sync and startle rise. Confirming the orchestra only plays when every instrument stays in tempo. 2 weeks later, personal echoes resound. Mara wakes before alarms. Eduardo. Lines, central catheters, with steady hands. Ravi subsists on green tea over espresso. Hannah and Leela mail travel wedges to parents. Omar borrows a sunset lamp and logs his first HRV climb. Invisible souvenirs, thin strands of widened seconds now. Weave through their dendrites, like fine silver threads. At month's end, the museum exhibition time, folded unveils. Visitors cradle glass globes, whose glow fades in 90-second parabolas, breathing to match the arc. In a side chamber, a lattice clock ticks. Nudging it onto a granite plinth lets lasers show the beat-quicken gravity's signature under glass. No ushers hush the crowd. Awe manages silence. Dusk descends across housing tiers. Lantern drones spiral upward, halos pulsing incrementally, slower at each altitude, staining the twilight with stratified rings. Roofed-up windows blush amber red. Fans hum, pillows tilt by a paperback's thickness. Heartbeats over the city settle into faint synchrony, carving microseconds of calm for dreams and for dawn's deliberate approach. Salience relaxes. Default mode coasts wide, and cerebral tides flow unhurried. Seconds glide onward and seen, continuous, giving thoughts and bodies a little more room to breathe before night quietly enfolds them. The experiment ends, yet its ripples keep widening. Weeks pass, and the 7 volunteers find their personal routines absorbed effortlessly into their city's pulse. Mattresses remain tilted. Lamps still glide through sunset colors. Fans whisper at heart rate tempo. Lab servers continue to stream anonymized. Sensor feeds tiny green pulses from wrist cuffs arcing through fiber like migrating fireflies. Data scientists notice an intriguing resonance. The more often residents step into one of the public silence pods, the less often ambulances idle at curbside overnight. Correlation is not causation, but cardiology wards confirm a subtle downturn. In nocturnal arrhythmia admissions, a hospital administrator runs the numbers twice, then drafts a memo proposing that every staff on call spend 10 minutes in a hush chamber. Before night rounds, schools join quietly. Teachers replace the sharp morning bell with a low chime followed by one shared exhale, long and slow. Children take to it faster than adults, eyes closing in unison, desks creaking faintly as shoulders settle. Attendance charts show the usual. Monday morning rust vanish from gradebooks. No lesson on breathing is formally taught, yet the rhythm slips into lunch lines and playground swings. A 6th grader later writes in a report that the chime opens a door between outside time and classroom time, a phrase her science teacher slips into a grant. Application on chronobiology education. Commercial districts discover pragmatic angles. An indoor market shifts its ceiling fans to revolutions per minute slower. Shoppers linger longer, scanning stalls without anxious pacing. A bakery proofs dough on a turntable that rises a meter from dawn to noon, harnessing the loft height. Gradient shown in silence weak metrics. Crumb structure improves. Reviewers notice a patient chew quality. The baker, amused, paints a tiny inclinometer on the wall. Customers track the loaf's altitude like spectators at a balloon festival. Transit planners retrofit train cabins with broadband, hum-tuned to a pink noise slope that covers conversation but leaves conversation clear. Heart rate cameras mounted above doorways record a subtle synchronicity after 5 minutes of travel strangers' pulses, converging within 3 beats per minute. The effect persists even after transfer to older rolling stock, as though travelers carry a temporary bubble of widened seconds in their chests. A research satellite in polar orbit provides the next surprise. Engineers update its guidance firmware with an attitude-controlled tone derived from the city's public hum profile. Thruster firings become more efficient. Reaction wheels wear slower. The craft's microwave clock drifts a shade less per week. Spacecraft telemetry forums buzz with speculation. Is that tiny HRV-like wobble in wheel torque proof that biological rhythms can inspire machine longevity? No one answers definitively. But proposals for self-soothing satellites appear at the next aerospace conference. Meanwhile, a mountain observatory far from the city uploads spectrograms of quasar light, filtered through a new chronotect-influenced photometer. The device cycles aperture blades in a gentle taper, rather than snapping, mimicking the light slope of desert lofts. Signal-to-noise improves by a statistically modest but publication-worthy margin. Astronomers toast with lukewarm coffee, half-joking that the universe prefers to be asked questions in a whisper. Back on ground level, a small apartment on the 8th terrace becomes the first private residence to install a fingertip glymphatic sensor. Each dawn, the device reports clearance efficiency via a glow line on the headboard: green if nightly brainwash reached target flow, amber if not. The occupant tweaks pillow angle by millimeters until 4 consecutive greens appear. She emails, the manufacturer, to say the glow feels like a sunrise that begins inside my skull. Marketing somehow resists the temptation to lift the phrase verbatim. Policy follows culture. Municipal planners pass a bylaw encouraging temporal stewardship. New building permits must submit a light fade curve, a noise spectrum profile, and proof of one adjustable gravity lever, ramped floor, a sectional mattress, even a rooftop hammock zone. Critics call it boutique regulation. Advocates counter that the same zoning once mandated fire escapes and air filtration. Within 12 months, renters' associations list incline angle next to square footage. The more the fabric stretches, the subtler the weave becomes. Artists hold a midnight performance near the river. Dancers roll down shallow ramps while carrying bowls of bioluminescent algae. Each step timed to a breath count visible on hovering drones. Spectators watch in near silence. Someone later releases a field recording. Nothing but faint footfalls, distant water, and collective exhale. It tops a streaming playlist labeled Gentle Dark. Scientists keep measuring. 5 million data points later, they publish a sweeping review. Average cortisol, down 4.5% citywide. Melatonin onset, advanced by 20 minutes on cloudless evenings. HRV median up 6% in residents who report at least 3 chronotect behaviors. The gains might sound small, they write, but biology lives on margins. Tiny deltas repeated nightly yield downstream cascades, clearer mornings. Steadier digestion, sharper declarative memory. Not everything bends perfectly. A sudden heat wave overrides comfort. Portable fans sold out. Noise floors spike as compressors. Switch-on salience peaks rise citywide. But now citizens possess tools. Hums are retuned. Light fade curves recalculated to compensate for warmer hues. Pillow wedges swapped for breathable mesh. Metrics settle within days. A real-world stress test. Past no banners declare victory. The city simply hums in a lower key. Children drift. Home past lantern drones that pulse fractionally slower at each terrace height. Workers stroll rather than hurry the last block, breathing in step with the distant drone. In bedrooms, thousands of readers close books as lamps glide to ember. Fans hover at pulse tempo. Pillows lean in quiet sympathy with the heart's slower rise of blood to head. Up in orbit, astronauts patch a memory foam wedge to the sleeping bagwall of the station's cupola. It angles barely 3 degrees, meaningless in micro-G, yet the familiar tilt soothes. On mission log day 187, one cosmonaut writes that dreams feel wider, like walking halls that echo longer. Mission Control prints the note, pins it beside equations once used to predict millisecond lags. A technician chuckles. The math led them to silence. Silence led to longer hauls in dreams. Medatum brings a lunar sunrise program. Pillows in museum halls let visitors recline, breathing timed to match the moon's slower gravity. A father stands watching his daughter exhale. Her breaths linger like the dust clouds Apollo once kicked up, hanging before the next footfall. He wonders whether she will ever know deadlines the way he did. A final layer folds in quietly one starlit evening when a radio telescope recalibrated with light fade actuators captures a whisper of fast radio burst from a galaxy half the universe away. The burst's intrinsic clock stretches across cosmic expansion, arriving as a low, rounded ping. Astronomers overlaid the waveform. On city HRV graphs, the shapes resonate. A commentator drafts the headline. Hearts and stars speak one rhythm. Numbers confirm nothing mystical, just harmonic coincidence, but the public adores the story. And in the co-authored myth, the city finally sees itself as a small, listening organ inside a much older body. Night deepens. Fans murmur, lamps glow ember, then wink out altogether. Mattresses lift heads by a paperback's thickness. Calves rest upon traveling wedges. Blood climbs with less strain. Pulses fall into soft accord. Breath rides its 5 and 8 count. Default mode waves bloom across quiet cortex. Overhead the sky turns gently. Satellites ticking faster. Distant pulsars, slower. Black hole horizons slower still. Every clock joined by flexible seams in spacetime's fabric. None of it stops. All of it yields. If this slow voyage through widened seconds has quieted your mind, or sparked a gentler curiosity about the clockwork of the night, you're welcome to leave a faint footprint below. Share where you're listening from, or what small change helped you rest. And if you'd like more unhurried journeys beneath the banner of science of sleep, simply tap subscribe and let the bell whisper when the next story arrives. Until then, may gravity settle softly on your bones, may lamplight dim at the rhythm of your breath, and may every elastic second cradle you toward peaceful dreams.